Hi, I'm Tom Mays from NodeWeaver, and I'm joined in the room by our CTO, Lorenzo Falaschini, and via Zoom by our CEO, Carlo DeFara. NodeWeaver is a software-defined edge operating platform that enables the nonstop operation of fleets of fully autonomous nanoclouds that can be deployed at any edge location, zero-touch deployable at any edge location, and run on any hardware. And when we say zero-touch deployable, at any edge location. Some of those edge locations could be, let's say, an edge data center location, but some of those edge locations could be, like we were talking earlier, a metal box on a pole or on the side of the highway. Or they could also be environments that are not connected to the internet at all, or transiently connected, like some of our maritime customers, where sometimes they have connectivity and sometimes don't. So we're installable anywhere and operational anywhere. And also on a wide variety of hardware, everything from traditional rack mount data center class servers to more unusual servers like smaller devices, different chipsets, and even down to small fanless, very quiet devices with very, very small CPUs. This one, for instance, is an Intel Atom with only 2 cores. So NodeWeaver is designed to optimize the full life cycle of your edge fleet. And in this segment, we'd like to illustrate some specific ways that we deliver optimization and efficiency by walking you through the different stages of a typical edge deployment. From our experience with working with customers, there's a planning phase, then there's a deployment phase during which they're getting everything installed out in the field, and then transitioning from now it's operational into long-term management and maintenance. To illustrate some of the challenges that our customers have experienced and how NodeWeaver solves those challenges, we're going to follow our project manager, Steve, who works for a Fortune 500 company and has been tasked with deploying edge solutions at several hundred locations around the globe. Now, since we only have about 20 minutes for this segment, we're going to jump ahead briefly in the timeline. And we're going to jump to the deployment phase. And I'd like to start by thanking 5 of our delegates in the room who kindly volunteered to do the live demo with us. Some may consider live deploying 6 edge sites from bare metal hardware, blank hardware, all the way up through fully operational live in a streaming session like this. Some may consider that to be a little ambitious, but really we believe that this is exactly what a field deployable zero-touch deployment system has to be able to do. So we always do live demos, and we're totally fine with this. So what we have provided our volunteer delegates, and hopefully you folks who are remote can see this. They each have a small server device. This is blank, just like it came straight out of the box from the manufacturer. They're plugged into the local network, and they have the NodeWeaver USB installer stick installed in the device. And we're going to ask our delegates to just plug those in to power and push the power button for us. Again, these are blank, just like they came right out of the box from the manufacturer. Bart here has a little different device. He's got a fanless, more industrial system. And again, just highlighting the fact that we can run on any hardware, even really small devices.
I'll be demoing here for the web audience. So as you can see, I've just booted a non-bootable device. So it's just stuck to the EFI shell. And we are now just deploying now NodeWeaver with the simple act of powering back off. We plug in the USB stick, which is carrying the NodeWeaver installer with the configuration meant for this site. Each one of your USB sticks is configured to be your personal site.
Thanks, Lorenzo. So this whole process, taking it from blank server up to fully deployed edge site, is going to take about 10 to 15 minutes. About the 10-minute mark, our delegates should start receiving an email telling them that the cluster is up and ready to be used, and gives them instructions for how to connect. So while that's working, we're going to go ahead and move on with the rest of the presentation. First, I'd like to thank our partners at Supermicro, Lenovo, and Intel for providing the demonstration hardware for us today.
Quick side question.
Yeah.
You're using USB sticks for all of this.
Yes.
Could you just as easily boot them off a Pixie server?
Lorenzo, do you want to answer the Pixie server
Could
question?
you just as easily boot them off of a Pixie
Yeah,
server?
we have also network installers. So we
Perfect.
can net boot it
Excellent.
and can grab the image from the internet. Of course, this is meant to deliver a full installation on an air-gapped environment. Today, we are connected with a small LTE router. All of these systems are just behind a poor connection. But this the USB installer with all the configuration and images in it is meant for air-gapped. But you can choose. Okay, we are also small ISOs that can really load via the IPMI or BMC of your server and just net boot them and just ISO boot or either Pixie boot, whatever.
Lorenzo, I dropped your picture-in-picture because the clicker wasn't working. Would you mind bringing the picture-in-picture back up? Okay, so before we get going, just what a quick disclaimer that, we lost our disclaimer. So while, these are examples, the examples that we're going to show and the challenges that we're going to show are really representative of the types of challenges that our real-world customers have faced. But much like you might guess, our friends here, they're kind of, very simple folk. And so they like things that are not uncomplicated, that are not unnecessarily complicated and not providing any additional value. So that's, hopefully you'll see that as our overall philosophy and everything that we do as we're going through the presentation. Still can't, okay. I'll just use this. Okay. So recently, Steve's management came and told him that he's been tasked with deploying several hundred sites around the world. The requirements for this project are really tight, though. So they have a very limited budget, only $5,000 per site for the hardware and the operating platform software. Additionally, they have some legacy applications that they need to support, as well as some newer containerized applications. And then because they expect the lifespan of these systems in the field to be pretty long, much longer than they see in the data center. In the data center world, we see a 3-year lifespan. Out in the field, because of some of the more logistical challenges, we see 5 to 7 years. So we know that, several years ago, VMware, VMs were the preferred approach. Then it was Docker, and then Kubernetes. They want to make sure that the platform they choose is flexible enough to support not only all of those technologies, but also whatever might come next. So in the interest of simplicity, their procurement team suggests that they just go with the same solution that they're running in the data center. But our friend Steve has experience with that as well, and he knows that the amount of compute power that solution takes is pretty large. And so that means that the servers that they would have to buy are larger, and that's too expensive for their budget. So they need something that's lighter weight. He also knows how much effort is involved in installing and maintaining those systems in the data center. So that's not really going to work either for being able to deploy this all around the world. So he starts looking for a different solution. Ideally, because again, this is during the planning phase, he's mostly looking at the cost of acquisition of hardware and software. So he starts looking for something that's really lightweight, that doesn't require a lot of CPU or RAM to run the base platform, and leaves most of the CPU and RAM for the applications that need to run, and also needs to run as fast as it would run on bare metal. By doing that, they'd be able to save quite a bit of money per site, and then multiply it over the entire fleet of several hundred sites. That's a pretty significant savings. So that's when he sees a video from Edge Field Day that talks about NodeWeaver, and finds out that we do everything that their data center solution does as far as functionality, but we do it in only 1 CPU core and a little bit more than 1 gig of RAM. And we also run as fast as it would run on bare metal. So that, of course, gives him a big cost savings per site on the servers, allowing him to run on smaller, less expensive servers. It also runs all of the applications that they need, from legacy all the way through Kubernetes and beyond. One nice benefit and a big difference between NodeWeaver and other solutions that are similar is that we require only 2 nodes to achieve full high availability. And that does not mean that we also need a remote witness if we only have 2 nodes. We do not need a remote witness, meaning we can run 2 nodes, full high availability, even in an air-gapped environment. So that alone represents a significant cost savings of not having to buy 3 nodes per site. Now it's 33% less hardware that you need to deploy at each location to achieve HA. And lastly, as a kind of a nice side benefit, is that because we run on any hardware, we're able to solve some of the supply chain diversity issues that we all experienced during the pandemic, and even now several years beyond, where customers are able to select any server that's available at the time from any manufacturer and intermix or run whatever they want to out at these sites. By the way, one thing I didn't mention is that the smaller servers also mean that there's significant soft cost savings in space, power, and cooling as well. So far they're off to a good start. They got a good decision on their technology stack that they're going to use at the sites. But the next challenge is figuring out how to get this installed and configured at hundreds of sites around the world. Again, procurement going with what's familiar, they suggest using their favorite integrator and having someone go out to each site and install these systems in the field. But again, Steve knows that trying to truck roll is one of the more expensive things that we do as far as a soft cost in IT. So he's looking for a solution that they can just ship out, much like a telco solution where the box just goes out to the site and then somebody there turns it on and it provisions itself. And so that's what he's hoping they'd find, and that would save them a ton of cost in the deployment. That's what NodeWeaver is designed to do. We are zero-touch deployable and field deployable as well. So overall, I mentioned simplicity and efficiency and optimization as being our big philosophies. We try to limit the number of steps that a human has to do, and even for those steps, we try to simplify them as much as possible. So for zero-touch deployment, it's as simple as drop ship blank servers, much like our delegates have received here. Drop ship those to a new site, unbox them. Somebody who's got very limited technical skills at the site can just unbox them, plug them in to power a network, and put in the USB installer and push the power button. At that point, the work that the human needs to do is over, and automation of our zero-touch deployment system takes over. It will boot automatically from the USB installer, install on one of the hard drives inside the server, reboot off of that now local hard drive, and then read the cluster configuration that's on the USB stick and apply it. So now it's got an IP address, a label, all the other metadata about how the cluster needs to be configured. When it comes back up after that, it will come up as a fully usable but vanilla cluster. Nothing at that point is configured yet. At that point, you'll receive an email. And so when you receive the email, it will contain links for how to connect to the cluster locally via the local IP address, and also remotely via a secure proxy that works even if you don't have any other remote connectivity services available at the site. So you don't need a VPN, any kind of SD-WAN, or any other capabilities at those sites to provide remote connectivity to the cluster itself.
So, question on the USB stick.
Yeah.
Is each node need to have a unique USB stick attached during the boot up, or can you reuse the same one across 2 or 3 nodes?
Oh, you must have read the material. That's an excellent question. Yeah, no, you use exactly the same USB stick for every server at that site. Yeah, and we'll do that in our next segment. We're going to do that as well, and we'll demonstrate that live, but great question.
Cool.
One other thing I'll take the opportunity to point out is that it takes about 10 minutes for the cluster to come up to that vanilla stage, but then it moves on beyond that, and it fully deploys all the applications, which we'll show in a moment. Yes, Bart?
You call it a cluster, but at least to me, a cluster is at least 2 or more nodes.
Yes.
Are we talking about a node or a server, or this box is a cluster for you?
It's an excellent question. That is a node.
Okay.
And since it's the first node, it becomes the leader of a, quote, cluster, unquote, even though it's only a single node right now. But it's a great question. We didn't really bake this into the conversation, but we are modularly scalable in single node increments. So some other alternatives, you have to scale in 3 node increments or whatever, whatever a different module of scalability is. We scale in single node increments. You start with a single node, Then in our next segment, we'll add a second node, but the process is exactly the same for every additional node that you want to add, and it's all fully automated.
So technically now we have 6 bare vanilla clusters
Correct.
being deployed now.
These are representing 6 totally different sites, different locations. And by the way, everything is all connected through just a cellular router. So all the emails and everything that you're going to receive are all, nothing is connected locally here. Everything's all done kind of like what we would see out in the field at a more remote location.
It's local network if you're connected.
And last thing I'll point out is that nobody has a keyboard or a monitor. So you don't need any additional, because it's zero-touch deployable, why would you need a keyboard or monitor?
Agree.
Also have received email and go and check.
Okay.
Okay.
So now that our friends, understand that the deployment is automated, they're used to configuring their data center applications manually. Obviously, that's not going to work at the scale of their edge deployment. So they're hoping that that there's a way to automate that. They've used IT automation solutions like Ansible or Terraform in the past, and those are great. But their team, and this is kind of indicative of a lot of the customers that we work with, a lot of our customers are application experts, people who are actually buying and deploying edge scale solutions today. They might be application experts or domain experts, but they don't have coding experience. They have very limited system administration experience. And they want something that's simple to use. And they're also concerned about even something as simple as modifying text files or markup language for each individual site, because that's really prone to human error when you're talking about hundreds of individual configurations that you have to put out. So that's the next lesson that we have learned, which is that we've created a tool that prevents the possibility of human error in creating the deployment package that goes to each site. So you simply build your environment in a staging lab, and we have a tool that will export that for you. Along the way during the export process, it interviews you and asks if you want to customize any of the configuration parameters for the new site that you're going to deploy that at. It validates it and error checks everything. And then when it's done, you simply copy and paste the output files onto the USB stick that's going out to that location. So again, if you're going to do a field deployable zero-touch install, you have to rely on it, working. You have to count on it working reliably, because if it doesn't, then you're still stuck with having to get the expensive sysadmins involved for every deployment anyway, which totally destroys the model. So we've learned a lot of lessons over the years of actually doing edge scale deployments, and this is one of the biggest things that we solve. So again, this bottom box here, you can see that it's a very simple model, very few steps, very few things that you can get wrong. Ship the service to the site, zero-touch deploy, even in air-gapped environments. I'll just take just a moment to contrast this to the depot model that a lot of other of our alternative products use, which is that for them, zero-touch deployment means that they ship blank servers to an installation depot, and a human still does the installation at the install depot, and then they repackage it, and then they just onboard it at the site that it's going to. There's a lot of additional steps and also additional complications that comes with that. In particular, sparing and the logistics of sparing gets really complicated, because if you have to maintain a regional spares depot, what is on the servers? What is on those spares? Is it custom configured for a specific site? How do you update those? So if you want to update and have a new version or new content on those, do you have to send somebody to the spares depot and they manually update everything? Or do you have to ship it back to the install depot and have it done there? NodeWeaver's field deployable kind of in situ deployment prevents all of that, because when the spares, when a spare arrives at a site to replace a failed device, you simply plug it in and use the same USB installer. It finds and joins the existing cluster, and everything is taken care of right there on site. You never have to worry about updating or anything, or having anybody at the site that has technical skills to be able to do it. Again, even in air-gapped environments. So getting close to the end here, in the economics of the edge, of course, acquisition cost is a big consideration, and we help with that. But as Carlo mentioned in the previous segment, we're focused on the entire, optimizing the entire life cycle. So the soft costs associated with deployment is also a major component. and enabling sites to be deployed in minutes by local unskilled staff is a big cost savings. So in the end, our friends were able to deploy their solution, hundreds of sites around the world on time and under budget, and everybody's happy. And then in the next segment, we'll move into maintenance and long-term management and maintenance of these sites. So while he's bringing this up, I'll just
That's
try
for the
to
web
answer.
audience, because our delegates already are logged into their systems. So this is the screen of the server we just booted in front of you. And we, as the delegate said, we had received all the emails. And we can just access our deployment. My laptop is connected to the local network, so I will join via the local IP. Our delegates weren't connected to our network, and were able to join via the remote proxy capability. So we log in, and we see that it's not only the operating system has been installed, but we have actual virtual machines running on it. So what the automated deployment did was to create the all the set of configuration needed to actually run the workload there. We created a bunch of VLANs, and then it downloaded the images from the USB stick that were ready for this site deployment, created the templates to run the VM, and actually spawned the VM. Just a little note on this, you see that some VMs are not booted because they are set for anti-affinity. For example, the Kubernetes backup master is not meant to run on the same node of the current master. So it's going to be waiting to deploy those VMs as soon as we add a second node. And well, that's it. So we have not only an installed operating system, we have a configured cluster, we have a deployed workload that we can access remotely.
Thanks, Lorenzo. Any questions?
Can you check my system, please? Because I didn't get an email yet.
Okay.
Yes, I will check.
The remote
You
access.
are.
The remote access that you talked about from the beginning do you have a rendezvous server of some type that?
Yes, it's a backend. This can be also self-hostable for large deployments. You can host your own proxy.
Okay.
It's a secure proxy that takes care of all the the protections. And you can enable or disable it remotely if you want. So you can shut down everything, and just after the deployment, you can just take it off and manage it via your preferred VPN or whatever.
He's Node E or Cluster E.
With IP, do you remember the IP?
That's going to be 240.
Okay.
Yeah, I just
Jim.
performed the old of the housekeeper test, which I'm not sure it's fully deployed, but she came in behind me and went, and unplugged this because she doesn't recognize what it is. What would happen in this situation while you're still configuring? If I turn it back on right now, will it resume from there, or?
So certain things will. If it's still in the process of configuring the cluster, then yes, it will still come back up. Configuring the cluster, not the application environment.
Okay.
If you want to redeploy the application environment, you would simply just rerun the bootstrap script that was running initially.
Right.
And then it will recreate everything for you.
Okay. I'm just saying, you're saying zero touch. Well, okay, it's one touch, right? Somebody's going to have to come in behind her and plug this back in.
Yes.
Yeah, of course.
Yeah.
But after that point, it's smart enough to go, oh, okay, I was here, or what would happen if it was in between there? There would emails go back and forth, or the client would pick up on this and go, hey, we need to go take a look at this.
Correct. Yeah. So we're trying to automate really everything that doesn't require a human to physically touch something, like plugging in cables or things like that. But there are some things like, we'll show you in the next segment how when you tell the system to run a bootstrap script to create the VMs and virtual networks and everything that Lorenzo showed, if it's in the process of doing that when the system loses power, what we want to protect from is that same process running over and over and over and over again. So what it does is it runs once, and as soon as it runs once, it gets flagged as I have already executed this process, if you wanted to do it again, you just have to delete it, wait a few minutes for it to clear out and see that, by default, every 5 minutes, it rechecks and it will see that, hey, this is empty now, so I don't do anything. And then you add it back again and it will rerun it.
Okay, good. We'll
Yeah, so
test that, right?
again, the system administrator would have to get involved at that point. Again, it's a safety mechanism, but yes.
Sure.
It's a good question. It's great that you guys are, it's always fun to have people break these in different ways and see how creative people are.
I figured you wouldn't mind.
No, not at all, not at all. All right, any other questions?
I think it's great. I mean, the remote connection in is a fantastic idea. It works. I mean, I clicked on the link and it worked, and
Yeah.
it
cool.
went. So that's a good start.
Bart,
Cool.
your had not the not uplink when you booted up, so it was not connected to the network.
Ah, no network
So-
connection. Okay.
Uh,
Here now.
now probably it is, or maybe it's a
I
fault
see
there
the
on the
link.
switch. And there's a cabling issue maybe,
Oh,
or
yeah.
was not plugged in.
We're gonna blame it on the
was
network
plugged in,
guy.
yeah.
Okay, so that's. By the way, in these cases,
ENF.
if the system has a PC speaker, it gets you warning, audible feedback. So if everything goes smooth, you will hear a kind of happy tune. Otherwise, you will hear something that resembles the Imperial March from Star Wars, and that means that something went wrong.
Mhm.
That has not. We have also options to, have RGB LEDs code. You can plug an RGB LED USB on the field in to pair with the USB stick, and you're going to have color codes for what happened. So you don't actually need the keyboard and mouse to decode, but just a little, like a Blink dongle, which is a USB driven RGB LED. So in that case, you would have noticed that way. You get the code for no link, and then you just plug it back, and if you want, we can re-roll it.
So I need to reboot it now, or
Yeah, just reboot it.
I can do it from if you want.
pull it out and back in again, or
It's yes, try it.
Yeah. Yep, that's it.
1, 2, 3, 4, 5.
So wait, wait 30 seconds
Yeah.
and hit the power button 6 times.
It powers on automatically, as far as I can see. That's on. That's on.
Yeah, I think it should go to the last state. So since it was
goes to
powered
last
on,
state, it was powered on.
yeah, it should go right back on.
And it does have a link now, so we'll see.
Nice. All right, good.
So that was a good question, and it's also good
Yeah.
to bring up this. But
Yeah.
this is completely foreseen, since if you go no keyboard, no monitor, also because sometimes it's at the edge is really impossible. You cannot hold a 15-inch external monitor while you are hooked to a pole. That's not going to work anyway.
I've
So-
heard of people trying.
yes, and they are not here to tell us.
Yeah, people on passwords.
Okay. Anyway, that's part of the harshness of the edge deployment.
Yeah.
So, and it's for this reason also this can become a thing to have a custom hardware that has a custom feedback set to maybe integrated LEDs for the states of whatever, even the internal application. So the modular system Carlo was talking about is just makes very easy for us to include and integrate extra hardware or specific